Hello there, this is Daniele from Toolchefs and welcome to this new video for the Stadium series. So what we're going to do in this video is we're going to have a look at variations, so the workflow that we use in Atoms, how we're going to export them from Maya, reuse them in a simulation scene to randomize the look of our crowds. In the second part of the video also we're going to see how we can set up our materials so that we can randomize the look of our agents at render time. In this specific video, we're going to use Arnold, but the same workflow applies to V-Ray, Renderman, and so on. So in this scene here, I have prepared some geometries. They are all skinned to this skeleton. The skeleton is also in bind pose. This is quite important, and each geometry has just one UV. And it's a good practice to have just one UV for each piece of geo, especially because when we bake out the texture, basically if you have more than one and you have not selected the right one here in the as the current UV, then you might end up having like funny looks of your crowds. So like having the geometries not being not displaying correctly in the viewport. Okay, so that's basically what we have here. So we're going to export a set of variations to disk. We're going to use a specific tool that is called the variation builder to create these variations. These variations then are going to have like a bunch of files in them. So we're going to have a variation JSON file, which will contain a reference to geometry files on disk as well as material files. Both these geometries and these material files could be different file formats depending on if you want to export the geometries in USD or a geos file, which is the Atoms proprietary format, or if you want to use Arnold or Renderman and so on, because depending on the renderer, of course, the material file will be different. So for Arnold, we'll end up having AS files. Then the JSON file will also contain a list of combinations, so the variation basically, that this variation will contain like a set of combinations of the geometries and materials for that specific variation. Okay, so this is what we're going to do. So let's start. We're going to open the variation builder that you can find under Atoms Variations Variation Builder. You can also use the button here in the shelf. The first part of the video, we're going to use the variations tab. So this tool, this part especially, is covered in another video on our YouTube channel, which is called Variation Builder Improvements. And in that video, we go into detail about all the settings that you can have in this UI. For this video, we're just going to have a look at most of them, but not all of them. So anyway, if you want to know more about this tool, you can check that video. So how this tool works is that we're going to build some variation types, which are basically they act as definitions for our variations. So let me build the first one so that maybe it's going to make a bit more sense. The first one, I'm going to call it summer, and then I'm going to attach some geometries to that. So it's going to be these ones. So we have the body, the t-shirt, the trousers, and the shoes. And then I'm going to deselect anything here in the tree. I'm going to press on this button. This creates basically an extra geo group that I'm going to call hair. And then having that selected, I'm going to select all the hair here. And I'm going to press this button here for adding the hair to this extra geo group. I'm going to set the weight for the none element to 0, so we don't end up having any variation without hair. And basically how the extra geo group works is basically for every variation that is going to be built for any variation type that we have here, we're going to pick one element from this extra group. So it would be one hair. In my case, I don't want any of my characters to be without hair, so that's why I set the none element to have weight 0. Of course, here you can have multiple variation types, so we can say I want to have spring. Here I'm gonna assign these 4 elements. So we have the body, the jeans, the shoes, and the sweater. And basically I'm happy with this setup. You can always export this setup with this button and then re-import it at a later stage if you want to reuse it. So let's jump to this side of the UI now. Here we have this number basically says to Atoms, I want to build 10 variations of this type and 10 variations of this type. In my case, I'm happy with just having 3 because we don't care so much about having so many variations now. Then we have the max attempt number, which is basically a number that tells Atoms to try 3 times before not creating any variation of a certain type anymore. So trying means that Atoms will try at each iteration. So for all of the 3 variations that we want to build like a unique variation, because of course you don't want to have variations that look the same. For building a unique variation, you need a unique set of geometries, combination of geometries and materials. So in this case, if for instance you had just 1 material per geometry in your scene, and then you would have like so the summer in this way and the hair in this way that we set up, we could only build 4 variations for the summer because we have just 4 extra geo. Again, if we have just 1 material per geometry in this scene. In our case, we have way more materials, and also here we have a lot of hair geometry, so we could really build way more. But anyway, in our case, we're just happy with 3 and 3 here. Then here we have like the section that this section basically tells Atoms how to look for materials that can be associated with these geometries. Okay. So again, here I build some materials in this scene. I haven't showed you already, but anyway, these are my materials, and they all follow a pattern. So as you can see here, let me show you side by side the name. So here we have body, for instance, and the body is called body underscore geo. All the materials for the body are starting with man underscore, and then they have body, and then like some sort of like identifier for maybe, you know, like the look of the material, and then they all end with underscore mat. So Atoms uses this the information that you provide in this section of the UI to rebuild a material name and then associate it with a specific geo when it's trying to build the variation. So for instance, let's say we have the body. For all the geometries anyway, we want to provide man underscore as a prefix, because as you can see here, all the material starts with man underscore, while the mesh, the meshes don't start with man underscore. I've added the man underscore because it's quite important to have unique names for your materials when you reach the render stage. This is because if you have different agent types that use materials that have the same names, you can end up having one overwriting the other if they're rendering at the same time, and that's why we have like the prefix here. So for all of your characters and agent types, it's always good to have like a prefix for your materials. Okay, again, a good practice that I would recommend using. Then the important part is also this section here. So we have underscore geo, this replacement, underscore geo, and underscore star underscore mat. So how Atoms works is like for each geometry, so let's say body geo, we'll prepend this man underscore. So we'll end up with a string called man underscore body underscore geo. Then it will replace underscore geo. So this will become man underscore body with this. So again, it will become man underscore body underscore star underscore MIT. Okay. The star stands for anything that can be, you know, used for building a valid name. So in this case, star basically matches everything that can be Afro, Afro-Euro, Asia, Euro, Euro-Asia. I use this pattern, so every material in this scene is built the same. So man hair 01 for the hair 01 as like basically a color, and then underscore mat. So basically this is good to go. This is good to, in my case, for the pattern that I've used in naming my materials. This rule is valid. It's gonna work basically. So I'm gonna close the hypershade. I'm gonna press on the create variations button, and this basically has just built my variations, which are basically render layers in my scene. I want to close this UI just because I'm gonna need to use the export tab, but in order to have the list populating, you need to reopen the UI again. So let's have a look at the render layers. Here we have 6 render layers, which are basically the render layers that have been built by the variation builder. Let me deselect it. So as you can see here, we have different hair with colors, and also different. The skin actually is always the same, but anyway, this one is a bit different. So it really depends on the randomization and how Atoms picks the materials. But anyway, the hair color is changing, and also the color of the clothes, and so on. So once you're happy with your variations, of course, you can build new ones here manually if you want. You can go again in the variation builder. In the export section, you see here the list now is pre-filled, and we can populate these values, so then we can export the variations. So the first thing that you need to provide is the agent type. So if you have your scene initialized with some agent type registered, if you press this button here, you will have like the list of all the agent types that are available in your scene. In my case, I don't have any, so I'm just gonna type it here. And this is the name of the agent type that we used in previous videos. You remember when we were setting up the agents in the Atoms UI. I'm gonna need to provide a destination variation file. So I'm just gonna save it here. I just created this folder, variation, then variations 1, and then I'm gonna variations. So this is the file that's gonna contain all the references to the geometries and the materials and so on. We need to provide also a skeleton file. So this is the main skeleton file. And then we need to provide also the skeleton root. If you want to export just one or more variations, you have to select them from here. Otherwise, Atoms will export them all. Then here you can select the renderer that you want. In my case, I want to use Arnold. Simple material conversion is something that you should use. I mean, you could use. You don't have to, but you should use. You could use in case you are using standard Maya materials, like in my case, Blean and so on. In case you have created already Arnold materials, you don't really need to check this one. Actually, don't check it. Because this is just used for creating a simple conversion from Maya materials to Arnold or V-Ray materials, really depending on, I mean, it will depend on the render that you have selected here. And also, we're going to enable bake textures so that we can bake the textures and they can be used when we're going to preview the agents in the viewport. Here we have the file format that we're going to use for exporting. I'm going to use the geos, but otherwise you can use USD. I'm gonna click run, and now Atom is gonna just export the variations on disk. Okay, so now the variations have been exported. If I check on a file browser, we'll find the variation JSON that I was mentioning, a bunch of folders where basically we have the geometries, the materials as well, like this, and the preview folder, which contains basically all the baked files for the baked textures for our geos. You might have noticed that also there is like this merge variation file option, and is checked by default. This is because if you, for instance, want to create a new export variation for a different agent type, for instance, a woman, let's say, and you want to add them to an existing variation JSON, like this one, you can select the variation JSON here and then say merge. This will basically merge basically just add to that variation JSON, and will actually create the geometries in the same folder structure for that other agent type. Otherwise, if you just turn this off, what Atoms will do will just create a new variation JSON for you. Okay, now let's have a look at how we can apply our variations to our crowd agents. Okay, so in this scene here, I have the same setup that we have created in the previous videos. Here, as you can see, we have the state of machine, agent type, and animation clips. And now I'm going to import the variation JSON in this scene. So you can go under variations and then import variation JSON. You have also the option of merging the variation, which is going to basically merge the content of the variation JSON that you are selecting with the content of the variation that you have in your scene already. With the import, you're actually clearing whatever you have in your scene and just importing what you have in the selected variation JSON. It's just you're overwriting basically what you have in your scene. In my case, I don't have anything in my scene, so I'm just gonna import. And one thing, then basically you can check whatever your variations. So you can use the agent variation manager. And as you can see here, we have a list of geometries, materials, and geometry groups, which are basically our variations. One thing that I did by mistake earlier was to provide a name for the agent type that is not correct. So for instance, if I go here in the Atoms UI, you see Stadium Man instead of Main Stadium. So we can fix that by going here, call it Stadium Man, pressing OK. Then I can save by pressing Ctrl S. And now I can also export the variations to disk. Again, so we don't basically, now the variations are fixed and we can use them even in other scenes whenever we import that variation JSON. Because otherwise, once you import and then you start editing with this UI, if you edit anything with this UI, you're basically just modifying the content of this specific scene. You're not actually changing the file that was on disk. I'm gonna save this scene. Then here, what you have in the geometry tab, we have a list of geometries. We have their names and the files that, you know, like where actually they have been exported. We have a filter because you can, of course, also filter which geometries you can source from, you can basically get from a specific geometry file. The materials have like a path to a material file. So again, an as file, and then a bunch of properties for the preview. In this case, we're mostly interested about the diffuse path. So this is like actually that preview file, the texture files that were baked that I showed you earlier. And then here we have the geometry groups. So as you can see here, we have the all our variations for the spring and the summer. And here we have the combination of geometries and materials. And here we see in the viewport here how they look. Okay. So I can just save, close this one, although I haven't changed anything, but just anyway, I just saved it. Now I can create an agent group with a grid layout and a state machine. Let me set the Stadium Man as the agent type. And I'm going to create a grid of maybe, let's say, 5 by 5. I'm gonna change the display type to skin for now. And these are basically my agents, okay? Now, for applying the variations, just to go from the basics, so we don't skip any step. We can go under, we can press add on the add button here and go under rendering. You will find this variations module. So the variations module basically has this attribute that you can edit. And in here you can like type a name of a variation. So the variation names are, if we go back in the Atoms UI, no, sorry, in the variation manager, let me use the button here, which is going to be a bit faster. Is basically, these are the variation names. So it could be Spring 1, Spring 2, Spring 3, Summer 1, and so on. But these are just valid for this agent type, okay? You might have different names for other agent types that you have in your scene. In this case, we're just going to use these ones, okay? So I'm going to select that one. If you click on this thing, we're going to have a list of all the available variation names. I'm going to click on Spring 1. Nothing has changed because we don't have variations, the variation display type enabled. I'm going to enable it now. And now we see the variation. But at the moment, it's just this one for all the agents, okay? Which is not something that we want. We want to, of course, override this for each agent. So we can maybe go here and say, Spring 2, set value, and then we can keep going for all of them, okay? But of course, this is not a very desirable workflow because you don't want to set the variation for each one of your agents. But this, anyway, the way in which you can maybe, you know, if you decide that a specific agent needs to have a specific variation, you can enable the selection tool or the layout tool, go in here. So for instance, if you select any agent, you see this one actually matches your selection. And you can say this agent has to be Summer 3, set value, and now it's Summer 3, okay? So again, this is just to explain to you how the workflow works, because any tool that you works with variations is just gonna attach this module and then change the variation for your agents, okay? If you want to randomize them quickly, your best friend is the variation randomizer. So variation randomizer is this one. So with this tool, you have a full list of agent types and their variations on the left. You can select either the variations or even the agent type. Just press on this button here. If you don't want some of them, you just select them from here and then press the bin button. Anyway, I just want to have them all here. You can change the distribution if you want, and then you can click on the run button. One thing is that the default is on selected agents only. So in this case, because I had one selected agent, I want to make sure that the selection is cleared. Because by default, if this is on and nothing is selected, then it will actually randomize on all the agents. But yeah, in case you have something selected, it's just going to be randomize the selection. Also, with this enable distance, it's going to make sure that the agents that are closer than 150 in this case, units, they're not going to share the same variation. In our case, we have quite a we have very little variations, very few variations. So maybe we're just going to disable this one for now. But you know, if you have a big setup with a large crowd, a lot of variations, maybe that is going to help you to make sure that your crowds are randomized a bit more. So two agents with the same variations, they're not close. So we can press run now, and you see the variations have been applied. So if I press play now, everything is working fine. Maybe, you know, even in this scene, I can just maybe quickly create an Arnold light, maybe a sky dome. Let me just make it a bit bigger, like this. And I can maybe create a plane quickly. This. Let me apply this. And what we can do maybe is we can render this one. Let me enable Arnold. Yeah, Arnold is enabled, so it's the default renderer. Now I can press render. And here we have our render. So it was pretty quick to set up. With Arnold, you have the possibility to render straight agent groups. With other renderers like V-Ray, you can't do that. You need to cache out the simulation and then use the proxy. But yeah, so this is the way basically in which you can randomize your agents. Randomize the variations for your agents. And now let's have a look at how we can change our Arnold materials before exporting them, so that we can customize the look at render time. Okay, now we're back in the variation scene, and what we want to do here is we want to make a new Arnold material and assign it to the t-shirt, but also we want to make sure that we can drive this material at render time by passing some agent metadata to the material. So let me open the Hypershade, and let me create an AI standard surface here. And let me call it t-shirt, man t-shirt. Let's call it like this, man t-shirt. Okay, then I'm going to select some materials down here that I'm gonna use for getting some diffuse textures. Okay, because I want basically to build a switch so that basically we can switch the texture at render time. That was my material. I'm gonna copy paste them here. For the switch, we don't have a specific node, but we're going to use an AI ramp RGB. And this is because what we don't want to do in Atoms, we don't want to have you depending on the Atoms plugin. For instance, if you export an USD crowd cache and you want to render it on any system, on any software, then if you use just Arnold rows, you won't actually need an Atoms license running there as well. So that's basically our idea. So here what we can do is, like, we're gonna add a new pin in the ramp. We're gonna make sure that the interpolation is set to none for all of these colors here. Make sure that the first pin is at 0, second one at 0.5, and the last one at 1, and the type should be set to custom. So what we're gonna do here is we're gonna connect these three file nodes to these three positions of the ramp. So let me just create a file node here, just temporarily, so we can see the ramp attribute there. Then I'm going to connect the colors there, there, and there. One thing that you should be aware of is that the order that you see here is not actually the same order that you would think here as for the position of these colors here, because okay, the first one is this one, is ramp 0, but this one is actually ramp 2. And this is because this is the way in, is the order in which these were created. So of course this one was created before than this one, and that's why it's at ramp 1. If you are planning to have more colors here, so more pins, more positions in the ramp, you can you should make sure that the positions here are actually you know, at evenly spaced. So if you have 4, for instance, this one should be at 0, the second one should be at 0.33, the third one should be at 0.66, and the last one should be still at 1. So as you saw here, I've connected the ramp to the base color. Now I'm going to create an AI user data int and also multiply divide node. Here I'm going to connect the output value to input 1x and the output to output x. Here I want to see the input. On the multiply divide, I'm going to set the input to x to 2 and set it here to divide. So the idea basically is this. We're going to use this value here, this node, and the value that we're going to pass, the attribute that we're going to pass to this node to be like to drive the ramp, right? So we want to make sure that whenever we pass like a value between 0 and 2, we pick one of these textures here. So 0 divided by 2, so that's the idea. 0 divided by 2, we return 0, so we're going to pick the t-shirt white. If we do, if we pass 1, we're going to divide it by 2, so it's going to be 0.5, and we're going to pick the yellow. And if we do, we pass 2 and we divide it by 2, it's going to be 1, so we're going to pick the t-shirt red. And this is again because of that different order that we see in the ramp attribute here in the ramp RGB. So here also we can use like a name, and the name should start with atoms. I just copy pasted it from my like a text editor, just because I can keep track of this name that we're gonna use later as a metadata. The name is pretty important, like it's actually case sensitive, so you should always remember, like we should always keep track of these names that you use. So I'm gonna save this scene. I'm going to render just to see how it looks. So 0, okay, it's correct because that is the white one. If I do 1, it should be the yellow. It should be, but it's not, so there must be something wrong going on here. So 0, 0.5 and 1, this is 1, this is divided by 2. Okay, so color, maybe I haven't assigned that, let me see. And t-shirt, yeah, okay, because I didn't assign it to the t-shirt. Great, so so 0 should be white, yeah, 1 should be yellow, yeah, and if I do 2, it should be red. Great, okay, so this is all done. Now we can also create a new AI color correct, which we're going to use in conjunction with an AI user data float. And we're going to use this one as to drive the hue. So here, let me just create again one temporary node. I'm going to do it straight away. I'm going to attach that one there. Out color will go here. And then here the input will be that one. Here, let me call this one atoms hue. Again, the name should always start with atoms. And if we have a play with this, so here I think we have 2, which is the red. If for instance I say 0.5, if we render, you see here the color has changed, so that's working as well. So I'm going to set back everything to 0 as default value. I'm gonna save the scene. I'm going to create a new, oh, I have it already, so I have a new render layer with all the meshes that are needed here. So if I do select, actually, sorry, this one select, I think, yeah. Now I can select, all the meshes are actually the ones that I need. So I can open again the Atoms, sorry, the variation builder. And let me, so the agent type should be a main stadium again. Let me select a variation file. So we create it here. Skeleton file it will be atom scale. Let me select the skeleton root. I'm gonna call the simple material conversion because I'm gonna check that because all the other materials are still blends, and then I'm gonna enable bake textures here. Okay, great. So these have been exported. If you go in a file browser, we find that the materials have been exported. So we have the man t-shirt S. Here we have the previews. And if we check, the man t-shirt is actually being exported as an EXR. In Maya, we should make sure that if you want to use if you want to see that texture being displayed in the viewport with like when applying the variation, we have to make sure that the OpenEXR loader is loaded actually. So now let's go back to the simulation scene. Okay, so now we're back in the simulation scene. Let me import the variation JSON that we just exported. Here it is. Now we're going to create a new agent group with grid layout and a state machine once again. Grid layout is going to be stadium man 5 by 5. Set skin for now, and actually let me use the variation randomizer straight away. So there must be something wrong with the name of the main stadium again. Yeah, I named it wrongly again, so it should be stadium man. Sorry about that. So let me export again the variations, so I have those variations ready for next time. Okay, so let me use the variation randomizer. Great, so it's there. Run. Okay, of course, anyway, that's the only variation that I could have added. So if I now change to variations, this is the variations that I see. I can create a light sky dome. Let me create a plane as well. Okay, grid layout. Let me apply for this height. If I render here, this is what we see. Okay, so now let's apply our metadata. So the first one, we said that it would be the texture switch, and the value should be an integer between 0 and 2. So I'm going to again remove the atoms prefix, so it should just be texture switch. Let me do int, and then we can say for all my agents, select all, it should be a value between 0 and 2, randomize. So now if I render, so you don't see any change here, but you'll see that at render time. So as you can see here, we have the 3 different colors. And now maybe we can also add the hue, add metadata. So I think I can just type this one. And the value, let's just type a value between, so there will be a double. And the value will be between, let's say, 0 and 1. I think I'm happy with that. Just to make things simple. And if I render, we have also that variation. Of course, the hue doesn't affect the white very much, so that's why the white colors are still the same. But yeah, anyway, this is just a way to show you that you can also use those Arnold nodes for customizing your materials and also drive the look of the materials at render time. So yeah, this is all for this video. Thanks for watching.